Number 3. Shopping mall has 3 automated teller machines. Because the machines receive heavy use, they sometimes stop working and need to be repaired. Let the random variable x represent the number of ATMs that are working when the mall opens on a randomly selected day. So it tells us that, so you can have 0 of the 3, 1, 2, or 3 of them working. Here's the probabilities. And if this is a probability distribution like they say it does, this should add up to 1. So I'm just going to verify that quick. 0.15 plus 0.21 plus 0.4 plus 0.24 is 1. So that's good. A asks, what is the probability that at least one machine is working? All right. Probability that x is at least 1 is going to be 0.21, because that would be one of them working, or 2 of them are working, so it's 0.4, and it's plus because it's or, and then because they're mutually exclusive, and then plus 0.24 for a whopping grand total of 0.85. There's an 85% likelihood that at least one of them is open. All right. B, what is the expected value? All right, expected value is a formula off of our formula card. So my expected value of x is equal to the sum of x times p of x, which is equal to 0 times 15.15 plus 1 times 0.21 plus 2 times 0.4 plus 3 times 0.24 equals 1.73 machines. All right, so I would expect on any given day that 1.73 machines would be working. What is the probability that all 3 ATMs are working when the mall opens, given that at least one is working? So this is talking about, okay, probability that all 3 are working given at least one is working. That x is at least 1. Okay, so really what I'm talking about, instead of saying all 3, I'm going to say probability that x equals 3 given that x is at least 1. All right, so looking at the formula card, probability of A given B is the probability of A and B, so x equals 3, and x is at least 1, divided, or all over B, which is probably that x is at least 1. So that's going to be equal to, now, and again, and means intersect. That means both things have to happen. That 3 and it's at least 1. Well, at least 1 we did up here, and that was 85. Exactly 3 is 24. So when can both of those things happen? The only time that both of those things can happen is when x is equal to 3. So my numerator is the 0.24. And my denominator is the 0.85, which is 0.282. There is a 28.2% chance that all 3 of them are working if I know that at least one of them was working. All right, so now, last part. Given at least one ATM is working when the mall opens, would the expected value of the number of ATMs that are working be less than, equal to, or greater than the expected value from part B? So if we know that at least one of them is working, all right, that means there isn't a chance that none of them are working. The question is, so out of the 0.85, so really what we're talking about is removing the possibility of there being 0. All right, so now all of the options. So what would end up happening is my probability distribution would change, and it would be only out of these. Okay, so in other words, only out of these would be my new normal, or my new typical, and then the probabilities would change slightly, but what would end up happening is that, well, here, let me just write down what I would say. Since at least one is working, the expected value, or the expected, we'll say value, of number of working ATMs would be greater because we got rid of the possibility of 0, the probabilities of 1, 2, or 3 would each increase. And when multiplied by 1, 2, and 3, the expected value of x gets increases. There you go. And again, going back to what I was saying up there, because my new typical, my new distribution no longer includes this, all right, no longer includes the 0, so I now only have 1, 2, and 3. So these probabilities each would have to increase because they'd have to add up to 1. If they each increase, then when I multiply them down here, it would just be these 3. All right, this would increase, this would increase, this would increase. Well, this one was 0 to start with, so only these 3 contributed to making the 1.73, so the overall expected value would also increase. All right, so number 3 was just on probability, and we cranked that one out in 8 minutes. Nice job.